In this video, I'm going to disconnect the upper drive from the lower drive, that is the upper weight from the lower weight, and just have a closer look at the operation of this reciprocating drive on top. If I do that, lay that weight there. Now this, you can see, is free to spin, free to rotate on a good bearing. And the drive itself is rocking this shaft, is oscillating it, but there is no circular component to this drive at all. It is completely linear. As a result of that, when the drive is operating, the weight is being impelled two times during each rotation. That is, two impulses 180 degrees apart. Because this is a linear drive, if we had a second assembly, an identical assembly mounted beside it, close to it, driven by the same crank operation, but 90 degrees out of phase, then the lifting effort would be cancelled out, because as one weight is rising, being lifted, its partner beside it would be falling. So the effort is virtually cancelled out. And that is a really big advantage of this drive. And you see, this does not apply to a rotating drive, to the elliptical or circular drive, because although that drive, the weight can be and must be dynamically balanced, it still takes energy to drive it. Whereas when this is running, the input energy really is minimal. And I'd like you just to notice the speed that this weight accelerates at as soon as it self-times. For some highly technical reason, it seems to work better with its rubber bands in place. Here we go. Nearly. There. Did you see that? It times itself. And that really is taking very, very little effort to produce the inertial energy stored in this revolving weight. So you can imagine if there were 4 of these units, all timed 90 degrees out of phase, this input energy would be virtually balanced out, and the only effort required mainly would be that required to overcome bearing friction, which is very little. So again, I hope that this adds a little more clarity to the drive, the operation of the Skinner device.